Today, we're going to take a peek behind the curtain of the universe, and we're going to do it by looking at something you've probably seen a million times: ripples in water. So, how can something so simple show us so much? Well, let's dive in and find out. Think about it. Waves are, well, they're everywhere. Sound, light, the Wi Fi signal you're using right now. But here's the catch: most of the time, they're completely invisible. So, how in the world can you actually see what a wave is doing as it moves, or bounces, or bends around a corner?
The answer is actually pretty clever and simple: a ripple tank. Basically, it's just a shallow tray of water with a light shining down through it. When we make waves, the light projects their shadows, letting us watch their secret lives play out right in front of us. This simple little setup is going to be our laboratory for today.
All right, first section, making waves visible. Let's get right into it and see how this thing actually works.
So, here's the plan. We're going to run a few quick mini experiments in our virtual ripple tank, and each one is going to unlock a fundamental rule that governs not just these little water ripples, but everything from the sound of my voice to the light from a distant star. First up, we're going to explore something I like to call the echo in the water. You probably know it by its more scientific name, reflection. Reflection is probably the wave behavior you're already most familiar with. Just think of a tennis ball bouncing off a wall or seeing yourself in a mirror. It's really just a simple, clean bounce. So let's see what that looks like in our tank. Okay, so here's our setup. First, we get these nice, straight, parallel waves moving across the tank. See them? Kind of like little soldiers marching in a line. Now, we're going to drop a solid, flat barrier right in their way. The key here is to watch what happens at the exact moment those waves make contact. And there it is. The waves hit the barrier and just bounce right off, heading in a totally new direction. But here's the really cool part. Notice the precision. The angle they come in at is exactly the same as the angle they leave at. A perfect, predictable bounce. That, right there, is reflection. Next up, understanding refraction. So what happens when waves don't just bounce, but are actually forced to change their speed? Okay, so if reflection is a bounce, then you can think of refraction as a bend. This happens anytime a wave goes from one environment into another, which forces it to change speed. A great way to picture this is a car driving from smooth pavement onto some thick mud at an angle. One wheel hits the mud first and slows down, and that causes the whole car to turn, right? Let's see it with our waves. To show this, we need to create two different mediums in our tank. We'll start with those same straight waves, but this time we're going to slide a block under the water's surface, creating an area that's much shallower. Now, let's watch what happens when the waves cross from the deep part to the shallow part. Whoa, look at that. The second the waves hit the shallow water, they slow right down. You can see them get all bunched up. That means their wavelength is getting shorter. And because of that sudden change in speed, the whole wavefront just pivots. It bends. And that's the whole idea. Change the medium, you change the speed, and that change in speed makes the wave bend. That's refraction for you. All right, so we've seen waves bounce and we've seen them bend. But now for what might be their most surprising trick: the power of diffraction, which is how waves can actually bend around corners. Diffraction is how waves seem to sneak into places you wouldn't expect. It's this natural tendency they have to spread out after they go through a little opening or pass by an obstacle. You could almost say it's like the wave is curious. It wants to explore the space behind things. And we see this happen in a couple of key ways. First, look at what happens when a wave goes through a tiny gap. It doesn't just shoot through in a straight line. No way. It emerges on the other side as these new, semicircular waves that just fan out everywhere. Then, check out what happens when waves go past the edge of a barrier. They don't just leave a sharp shadow, they actually wrap themselves around the corner, filling in that empty space behind it. This is exactly why you can hear somebody talking even when they're around the corner from you. So we've seen waves bounce, bend, and spread out in our tank. But why does this matter? Well, here's the thing. These aren't just little tricks that water can do. These are the fundamental rules that govern all waves everywhere. Let's bring this into the real world. That reflection we saw, that's an echo bouncing off a canyon wall. It's light waves bouncing off a mirror. Refraction, the bending, that's why a straw always looks bent in a glass of water. It's literally how eyeglasses work, by bending light. And diffraction, that's the whole reason you can hear someone calling your name from another room. The sound waves are bending around the doorway to reach you. And that is the big takeaway here.
The simple, beautiful patterns in a tank of water aren't just about water. They are a perfect visual model for the hidden physics that controls light, sound, radio signals, pretty much every wave that makes our universe work. We've managed to make the invisible visible.
So the next time you see the sunlight on the water, or hear a sound from far away, or even just look through a pair of glasses, you'll know the secret physics that's going on. So I'll leave you with one final question. Now that you know what to look for, where else are you going to notice waves in action? Thanks for watching.